Hello, my name is Trisha Figueroa, and I'll be doing extra credit problems 1 through 3 from and 5 to 12. So, the first question asks, does 17 divide into each of these numbers? And the first number is 68. So, in this section, we were dealing with div and modulus and everything of that. This is only asking if 68 divides cleanly with no remainder, or 17 divides clearly into no remainder into 68. So first question, you just do 68 divided by 17, or you can write the notation that I have, 17, 68, and then you get 4, which is true. It divides clearly into the number. Next question, you go into 84. Just mathematically looking at it, 17 is an odd number, and it's closest, 84 is closest to 68 than all these other numbers, and you can tell that 17 times 5 is going to be 85. So it does not divide clearly. It doesn't divide clearly into 5 or where it equals 5 or 4. You have a remainder with when you divide 17 into 84. So it's not true. C, you have 357. 357 divided by 17 is 21. 17 times 21 is 357. Works both ways, so that's true. And then 1001 divided by 17, it just doesn't work if you put into your calculator. You get about 58.88, which means it's not a clear number. Not true. Number 2 are just asking for the div and the mods of the following numbers. So again, div is just the number you get when you divide with no remainder, and then mod is the remainder that you get. So 19 div 17, so 19 divided by 17, you get 1, since 19 or 17 can only go into 19 one time. 19 mod 17, basically you can do this one in two ways. You can do it mod 19 mod 17, or since we know that the div of 19 and 17 is 1, you can do 2 mod 17, because 19 minus 17 is 2. It's going to give you the same answer regardless. So you have a remainder of 2 for B. For C, you have negative 111 div 11. You just do negative 111 divided by 11. You get negative 11. Pretty simple. But when you do mod, you get no negative answer. You're just looking for the remainder left over. So you're looking for the close, you're doing negative 11 times 11. Negative 11 times 11, you get 121. Negative 121 minus 111, you're going to get 10. So you're left with a remainder. 789 div 23. You just divide 789 divided by 23, you get 34. And what you can do again, like I said for B, you can do either 789 mod 23, or you can do 789 minus parentheses 34 times 23, and then you can do the remainder of that, and you still get 7. So we don't have to worry about it. 0 div 19, when you divide any number into 0, you're obviously going to get a 0. Same thing. But when you do a mod, when you're looking for a remainder, there is no remainder when you mod a number into 0. Does not exist. 3, these are a little more kind of like word problems in a way. What does a 12-hour clock read? So here I decided to do it a different way. Number 8, I did for A. You have 80 hours after it reads 11 o'clock. So for what I did was that I was looking for an even number. I was just looking for how much is left over when I do 80 div 12. 80 div 12 is 6. If you do 12 times 6, you get 72. So I could have written 8 mod 12. You have 8 hours left over. You do 8 plus 11 plus 8. Then you get 11 plus 1, because you're going to subtract 1 because it's a 12-hour clock, and then it resets to goes to 12, and then you just do remaining 7 hours, and you get 7. For B, it's 40 hours before it reads 11 or 12, so 40 mod 12 is 4. You do 12 minus 4 because it's before, and you get 8. And then 11, or for C, it's 100 hours after it reads 6. So 100 div 12 is equal to 8. 100 mod 12 is equal to 4. So I am looking for 6 plus 4, which is equal to 10 o'clock, because it's after. I'm going to skip 4 because I didn't choose to do 4. 5, you're just finding a number such that A fits the criteria. So A is going to be equal to 43 plus 23k. You can rewrite this because of mod rules that we learned early in the chapter. Um, so I need A to be a number between negative 22 and 0. So let's just say I chose a number for k to be negative 2. Negative 2 times 23 is negative 46. 43 minus 46 is equal to negative 3. A is equal to negative 3, which is between the parameters of negative 22 and 0, which is correct. B, we move on to A7 is equal to 17 mod 29. Again, we can rewrite this as A is equal to 17 plus 29k because of mod rules where k is an integer. If k is equal to negative 1, or if k is equal to an integer, it has to complete the condition that negative 14 is less than or greater to a, and then that a is less than or greater to 14. So again, I chose that k is negative 1, a is equal to 17 plus 29 times negative 1, 17 minus 29, you get a is equal to negative 12, which fits the parameters. Next question, a is equal to negative 11 plus 21k, again because of mod rules. Now we're looking for an integer to, or for k to be some type of integer that fits the parameters of 90 is less than or equal to a, but a is also less than or equal to 110. So I chose 5. A is equal to negative 11 plus 21 times 5. A is equal to negative 11 plus 105, since 21 times 5 is 105. A is equal to 94, which completes our condition. 6. Decide whether each of these integers is congruent to 5 modulo 17. So if you're looking for congruency, you're just basically looking for a number that has the same remainder as 5 mod 17, which is equal to 5. So it is simple. For A, you're looking for if 80 is congruent to 5 modulo 17, 80 mod 17 is equal to 12, not congruent. B, 103 mod 17 is equal to 1, not congruent to 5. Mod 17, not at all. C, negative 29. So for this one, I decided to do it a little differently. I multiplied 17 by negative 2, and then I added 29 to that to get 5. So negative 29 mod 17 is equal to 5. Easy peasy. Negative 122. I found what number is closest, but more greater than negative 122 using our mod number. So 17 times 8 is 136. 136 minus 122 is 14. Is 14 mod 17 equal to 5 mod 17? Not at all. It's not true. 14 mod 17 is equal to 14, which is not equal to 5. Moving on to 7. These are a little bit more difficult, but basically what you can do is that you can solve the interior to get your exterior one. So negative 133 mod 23 plus 261 mod 23, since mod 23. So you can either write it out fully and solve it like that, or you can condense it like I did on the left side. So negative 133 plus 261 is actually equal to the equation because of mod rules. We're dividing, or we're modding by the same number. So you can just add those two and then you're modding by the same number on the outside. So I add the parentheses, I get 128 mod 23, which is equal to 13. For B, it's going to be the same thing, but this time we're multiplying. 457 times 182, you're modding by the same number inside, so it's like terms, and you're modding by the same number outside. So 457 times 182 is equal to 83,174. You mod that by 23, you get 6. C is a little more difficult because you have exponents on the 99 and on the parentheses. So you can expand it to 99 mod 32, 99 mod 32, mod 32. Since you can expand the 99 twice, and then you can expand the 3 afterwards. But first we're going to focus on the 99 twice. So 99 mod 32, 99 mod 32, mod 32 cubed outside of mod 15. So 99 mod 32 is equal to 3, so that works for both. So we can do 3 times 3 to condense it. 3 times 3 mod 32 cubed mod 15. 9 mod 32 cubed mod 15. And we can just distribute the 3 to, sorry, let me backtrack. 9 mod 32 is going to equal 9. So now that we know it's equal to 9, we can distribute the cube to 9. So 9 cubed 3 is equal to 729. 729 mod 15 is equal to 9, or is equal to 9. Simple as that. Again, we have exponents on the actual, or on 3, and we have exponents on the outside the parentheses. So first I'm going to do the exponent on 3, because we basically proved that we can work with the exponent first without having to expand the mods. So 3 to the 4th power is 81. So 81 minus mod 17 squared mod 11. 81 mod 17 is 13, so 13 squared mod 11. 13 squared is 169. Mod 11, 4 mod 11 is equal to 4. For 8, it asks us to convert the decimal expression of each of these integers to a binary expression. So basically what we're going to do is we're going to divide the number by 2. And then let me backtrack, sorry. For this, you can do this one of two ways. You can do 231 is equal to some number div 2, and then with that remainder, you can do that remainder mod 2, and then you get that. But this is a simpler way. So 231 is equal to 115 times 2. That is equal to 230 plus 1, because there's a remainder, because you can't get 231 cleanly by multiplying by 2. We take the first number in the equation, 115, and we drop it down to the left-hand side, and we solve for that. So 57 times 2 plus 1. Again, we're going to keep going down. 57 times is equal to 28 times 2. Keep going down. 28, 14. Keep going down. Keep going down. And keep a track of all the remainders that we have here. So 1, 1, 1, 0, 0, 1, 1, 1. And we want to whittle it down until we get this number to be 0. Now, for a binary expansion, you actually want to work your way backwards from what you solved. So this will be the first number in the binary sequence, and this will be the last number in the binary sequence. So if we go from back to front, we get 1, 1, 1, 0, 1, 1, 1 is a binary expression of 231. Move on to B. It's the same thing, but it's just going to be larger because it's a larger number. So 4532 is equal to 2266 times 2 plus 0. 2266 is equal to 1133 times 2 plus 0. 1133 is equal to 566 plus times 2 plus 1. 566 is equal to 283 times 2 plus 0. Keeps going, keeps going. You work your way backwards again. So you get 1, 0, 0, 0, 1, 1, 0, 1, 1, 0, 1, 0, 0. Again here, 1, 0, 0, 0, 1, 1, 0, 1, 1, 0, 1, 0, 0. Perfect. Now C is just even a larger representation. Again, you just keep dividing, you keep brute forcing it all the way until you get your number. So here, I'm just going to read out our remainders. So 0, 0, 1, 1, 0, 1, 1, 0, 1, 1, 1, 1, 1, 1, 0, 1. We're going to read them backwards to get this. 1, 0, 1, 1, 1, 1, 1, 1, 0, 1, 1, 0, 1, 1, 0, 0 is our binary expression of 97,644. I'm going to stop here, and then I'm going to record the rest of the problems.